In this chapter, we're going to look at the graphical representations of data. In this lesson, we'll be looking at circle graphs. All right, hi everyone. In this lesson, we're looking at circle graphs. And circle graphs are really good for giving you a sense of how the whole is broken up into different segments, different groups here, okay? So, I mean, I think that's pretty clear if you've ever seen a circle graph, right? You've got your circle here. That represents the entirety. So, for example, maybe this is the school, okay? And then what happens here is maybe this is here are your grade 10s, this is the number of grade 11s, and then here are your grade 12s. And so that gives you a sense of proportionally how the population is put together. Okay, that's really what a circle graph is really good for. The way they build them here is the angles that you have at the center here are going to be related to the percentage that group is of the whole. Okay, so for example, if you've got one here that's let's say 25% of the whole, well, 25% of the 360 degrees in a circle, that would be 90 degrees, and so that's what you would have here. You'd have a 90-degree angle. Okay, and that's kind of just to give you a sense of how that works. Now we're going to look a little bit more specifically at that in just a bit, but first let's take a look at some examples. Okay, so this question we read that the following circle graph shows how people in Craig's office building get to work. There are 350 people working in the building. So here we go. So here's the circle graph that gives us the breakup of the different ways people come to work here. Now, you need to have a legend to help you interpret this. Okay, so here we go. Let's take a look at the first question here. It says, what percentage of people walk to work? Okay, well, walking is this really dark one, and when we look at that segment right here, that's 3%. Now, then the question is, how many people does that represent? Well, this is 3% of the whole, and the whole in this case is 350 people. So what we have to do here is figure out what 3% of 350 is. So remember, 3% means 3 out of 100. And then the word of in mathematics typically means multiplication here. So what we're going to do, is we're going to take that 3 out of 100, 100, and multiply that by 350. And so we get, what is that, 10.5 people. Now, that's a really kind of a weird answer to get here. So that's okay. What we'll do here is we'll round that up. So that's approximately 11 people out of Craig's office walk to work. Now, the next question is, what percent of the people come to work in a car? Okay, so we have to take a quick look at this. And when we take a look at the circle graph here, that is about 61% of the graph here. So that's 61% of the people at Craig's workplace drive to work. Now, how many people does that represent? Well, let's take that, 61 out of 100. And once again, we're going to multiply by 350. So let's do that again. 61 divided by 100 multiplied by 350. And again, we're getting that decimal there. Let's round that up, though. So what we're looking for here is 214 people are going to drive to work. Okay? So that's how you would answer or interpret a circle graph that looks like that. All right. Now this next question here doesn't have a circle in it, and in fact it doesn't even really ask us for a circle, but what it's asking for does point in that direction. It says a pizzeria has tracked the sales of 5 different kinds of pizza, so cheese, pepperoni, vegetarian, Hawaiian, Canadian. Calculate the percentage that cheese and vegetarian pizzas represent of the total sales. Okay, so basically what they're asking us to do for these two pizzas here, the cheese pizza and then the vegetarian pizza, is what we're trying to do is figure out what percentage of all of the pizzas belong in those two categories here. That is the first step towards creating a circle graph. Okay, so first of all, to figure out what the percentage is, what I need to do is figure out what the total is. So let's go through and let's add those together. So 29 plus 46 plus 45 plus 17 plus 25. And so we're looking at a total of 162 pizzas that have been sold. So now, for cheese, okay, we've got 29 pizzas out of the 162 sold. Okay, so let's do that. 29 divided by 162 is equal to, whoops, what did I see? I saw approximately 17.9%. Okay, and actually, you know what? Who am I kidding? We're not going to write it like that. We're typically going to round that to the nearest whole. I mean, if you're asked to go to the nearest tenth, that's okay. This is approximately 18%. Now let's take a look at the vegetarian. That is 45 out of 162. So let's go to our calculator here once again. 45 divided by 162. And when we move that decimal point over here, that's going to be approximately equal to 20, well, if I round that to the nearest whole, 28%. It's approximately 28% of the population there. Okay? Now, just to take this one step further, this is not what the question asked here, but let's just take this one step further here. What we would then ask, and you're going to see us ask this in just a moment, but we'll do it here, is if I was to create a circle graph, what angle at the center of the circle would open up to that segment, or that sector that's going to be equal to the cheese pizza? Well, let's go up here. Let's grab this. Here's my percentage for the cheese pizza. What I need to do is figure out what angle this is. So this is 18% roughly of multiplied by 360. And so what we're seeing here is that would amount to a central angle of about 64 degrees. Same thing with the the vegetarian pizza, we got 27 there. If we multiply that by 360 degrees, okay, that's going to be a 100-degree angle in our circle graph that would open up to that particular segment. Or sorry, sector. I keep saying segment, I mean sector. Okay, sector of that circle. So anyway, this is where we're going in just a moment. Okay, so another question here. We got, Jose has organized a budget for his first year of living alone. He plans to spend $2,500 a month in total. If he spends his money in the proportions shown in the graph below, how much money does he spend on bills and car costs? Okay, so remember, this represents his whole $2,500 budget. The size of each of those segments represents the percentage or proportion of the whole that he's dedicating to those costs there. So let's take a look at car costs right now, because one of those things that we're looking for is car costs. That's this thing right here. That's 12%. So we know that he's putting 12% to car costs. So 12 over 100 multiplied by $2,500 here. Let's figure out how much is he putting towards car costs. So it looks like he's putting $300 to car costs. Okay? Now we'll go down here to bills. Okay, this is nice. Bills is the dark one there. That's easy to identify. That's 17%. So 17 out of 100 multiplied by 2,500. So 17 divided by 100 multiplied by 2,500, and we get $425 on bills. So altogether, he's budgeted $725 on the car and his bills. Okay, if you put those together. And so that's what you would do given the information in this form. Okay, in this question we read, the usage of different colors in a drawing is given below. So basically here are my colors here, and we're getting the proportions of the colors used in the picture here. So draw a circle graph to show their usage percentages. Also specify how much each part measures in degrees. Okay, so first of all, what we're going to do is we're going to take these percentages right here, and we're going to convert them into a degree on the circle here. So now remember, to get the measure of each part in degrees, we simply multiply the percentage values by 360 to get that percentage of the circle. So for example, for 13 degrees, well, I'll do it over like this. For 13 degrees, I'm going to do 13 divided by 100 multiplied by 360. Okay, and so we get 46.8 degrees. Then we'll do 38 divided by 100 multiplied by 360. and I get 136.8 degrees. 136.8 degrees. 7 divided by 100, 7%, multiplied by 360, 25.2 degrees. And then 42 divided by 100, multiplied by 360, 151.2 degrees. Okay, now just to verify that we've done this correctly here, let's add those all up. That should give us 360. Okay, so 46.8 plus 136.8 plus 25.2 plus 151.2. I know I'm way off there. Let's press enter, and hopefully we get 360, and there we do. Good. So that's what we were needing here. So now I'm going to draw a circle, and actually I did that already. And what I did is I used a cup and just traced out the bottom of the cup here. Now I need a starting point for all of this. So I just identified the center and drew out a radius here. That's where I'm going to start to measure things from. So I'm going to grab my protractor here. Red has a central angle of 46.8 degrees. So I'm going to take my protractor here. Okay, make sure that I put the protractor, the little crosshair right there on the end of the radius, the center of the circle. And then what I'm going to do here is I'm going to go out here and measure 46.8. So 10, 20, 30, 40. There's 45. So 46.8 is going to be really close to 47. And make that little mark right there. And then I'm going to connect that to the center of the circle. This is going to be red, and it's going to be 13% of that circle. Then I want to put, green in. Now green is 136.8 degrees. So this is where I left off, and I'm going to start there. So I'm going to put the little crosshair again at the center of the circle. I'm going to line up that line that I just drew. And then starting here on the inside, I'm going to go up to 90, 100, 110, 100, 130. 130, there's 105, 106.8 is going to be just about 137 there. And then I go to the center and I connect to that point right there. And then this is green, and this is going to represent 38% of the circle. Yellow is going to be 25.2% here. Or sorry, 25.2 degrees. 7%, but 25.2 degrees. So once again, I put it here. Line it up against the line that I just drew. Except this is going to be a small one because it's only 25.2 degrees. So 10, 20, and it's just a hair over 25. So right there. Now I connect the center of the circle out to that line. So here's my yellow. And it is 7%. And now, I've only got one color left. So I'm hoping that this section right here is going to be really close to 151.2 degrees. Now, in all honesty, it might not be because I really just kind of free-handed where that center is. If I was to have used a compass, that would have been a lot better. But here we go. Let's see how well I did. Okay. So actually, I'm going to extend this line a little bit just so that I can measure this off a little bit clearer. Just going to put that out there a little bit. So now I'm going to put the center right there, line it up, and let's take a quick look. Oh, I'm not that bad. So 10, 20, 30, 40, all the way out here. Actually, I am just a hair. The angle that I'm measuring here is about 149 degrees, which is pretty good. All said here, that's pretty good based on the fact that I was just doing this by hand with, by the way, a protractor that I just printed off of the net here. I just grabbed a picture and cut that out here. And so this is 42% for the blue. Okay, so hopefully that gives you a sense of how these are built from the data that you're given. Right, in this question, we read that a survey was conducted where each student was asked to pick their favorite type of flower activity. The results were then recorded in the table below. Complete the table and create a pie chart. So the students were given these 4 options here, and then they just did a tally. So altogether there were 56 students talk to. So this circle here represents those 56 students. Okay, which we're hoping, by the way, will be a model maybe for a larger community, but we don't know. So this is just for those 56 students. Now, we're going to convert each of these numbers into a fraction. So that's just going to be 56, sorry, I wrote 15, I said 56. 15 out of 56. This will be 25 out of 56. 5 out of 56, and 11 out of 56. Now, I don't really need to do this down here because I know the total here is going to be 1. Basically, I add those all up, I will just get 1. Now, let's convert those into percentages. And actually, what I'm going to do right now is I'm going to go through and I'm going to convert it to percentage, and then I'm going to immediately convert this percentage into a degree. Okay? So what I'm going to do here is, first of all, we're going to take that 15 divided by 56, and I'm seeing 26.8. Let's do that. So 26.8%. And then, because I've got the nice decimal here right now, I'm going to multiply that by 360. And that's going to get me 96 degrees. I'm just going to round that to the nearest whole. Then we move on to the next one. 25 divided by 56. So our percentage here is going to be, remember, I got to move the decimal 2 places over. So 44.6%. And I'm going to multiply that by 360. And when I round that to the nearest degree, I'm going to get 161 degrees. Next is 5 divided by 56. If I move the decimal 2 back, that's going to be 8.9%. Let's multiply that by 360. Get 32 degrees. And then finally, 11 divided by 56. Move the decimal 2 back, so 19.6%. And if I multiply that by 360, I get, rounded to the nearest degree, 71 degrees. Now, let's just double check that this works here, okay, because this is ultimately my goal. So let's just make sure that 96 plus 161, plus 32 plus 71 equals 3, and it does equal 360. Okay, that's good. I feel really good about those values here. So now, it's a matter of taking these degrees and moving them over to my circle. So now, I didn't create this circle, so I really am just going to kind of guess at where the center is. That looks about right. And then I'm just going to draw a radius there. That's my starting point. So now, picking daisies should have been 96 degrees. So I put my little crosshair there at the center of the circle, line up that side with my radius, and then I go out to 95, 96 degrees. Okay, and I'm going to connect that point right there to the center of my circle. So here, this is picking daisies. Next, we've got smelling roses, and that's 161 degrees. And remember, I start on that line here, so I line up that crosshair at the center of the circle. Okay, I put the edge of the compass, protractor, along that radius here, and now I'm going to measure out what was 161 degrees. So, and I'm starting on the 0 here, so 61 degrees. That's way down here. That was a huge chunk of the circle. Okay, so this is smelling roses. That was an enormous chunk of the circle. Not quite half, but pretty close here. The next one was eating dandelions. Okay, oh, whatever. Eating dandelions. So now we start there, and we measure up. Just in my head, I'm thinking, man, that would be really bitter, I would think. Anyway, I don't know. I've never eaten them. Didn't know you could eat them. So here we go. So starting at the center of the circle on the crosshair, we go along the radius, and then we come out. We come out here. And we're going to measure out 32 degrees. So 10, 20, 32. See, now I'm curious as to what dandelions taste like. So this is going to be eating dandelions. Okay, you know what's going on from there. Now, I've only got one left here, planting tulips. This, I'm hoping, is about 71 degrees. So I'm just going to double check that. Now, I'm going to extend that line there so that I can read the angle off. But I'm hoping that this is really close to 71 degrees. Because if it is, I'll feel really good about my measurement at this point here. So again, I line that up at the center. Line it up along there, and I go out here. Oh, wow, that's almost 100% bang on. Feeling really good about that. So planting tulips. So I feel pretty confident that this circle graph that we're seeing here is a pretty good representation of how the population is broken up into those different groups. Okay, everybody, this last question that we're going to do here says, Ashley surveyed students at her college to find out how they commute to school. The results are shown in the table below. We're going to create a circle graph of the data here. Okay, so this one here is basically leaving it up to us to do this work here. So we've got means of travel along here and then the number of people. Now, in order to convert these numbers into the appropriate degrees, what I got to do is I got to get them into percentages. To get them into percentages, I need to get a total. So that's the very first thing I'm going to do. So we're going to take 75 plus 20 plus 5 plus 75 plus 10 plus 15. And our total is going to be 200. Sorry. So now what I'm going to do two things here. Just like I did in the previous question, I'm going to quickly convert that number right there into a percentage and then immediately into an angle. So 75 divided by 200, 37.5%. So I'm going to multiply that by 360, and that gets me, 135 degrees. Okay, so I'm going to try to do it in one step here. Next, 20. 20 divided by 200, it's 10%. Multiplied by 360 is going to be 36 degrees. 5 divided by 200 is 2.5%. Multiplied by 360 is 9 degrees. That's pretty small. It's going to be a little tough to draw there. 75. Okay, well, 75 I did just a moment ago. I already know that that's 135 degrees. That's okay. 10. Now, seeing as 10 is half of 20, I'm assuming that this is going to be half of that. I'm assuming that this is going to be 18 degrees. But let's figure that out here. So 10 divided by 200, and then multiply that by 360. Yeah, and there we go. That's 18 degrees here. And then lastly, 15 divided by 200, 7.5%, multiplied by 360, and I'm getting 27 degrees. Now, just like I did before, I want to make sure that these numbers are working out here. So I want 135 plus 36 plus 9 plus 135 plus 18 plus 27. I really hope this is 360. 360. Good. So now I can convert this into my circle graph. So I'm going to start at what I think is about the center. And then I'm going to draw, close enough. Then I'm going to draw a radius, just as my starting point right there. And then here we go. So those that take the car alone is 135 degrees. So I line up the crosshair at the center, put the side along my radius, and I'm going to measure out here 135 degrees. So this is going to be car alone. Then the carpool is 36 degrees. So I put crosshair there, side of the protractor along the zero there. 36 degrees. So that's not going to be too big here. So 10, 20, 30, 35, and then right here is going to be my 36. Connect that to the center. And this here is going to represent carpool. So already you've got a nice visual comparing the number of people that come in the car by themselves to the number of people that carpool. This is going to be even more dramatic. Motorbike is 9 degrees, so I line up that center there, line up the side along that radius, and I'm going to count out 9 degrees. Well, here's 10, so it's just a hair less than that. It's not very big at all. Yikes. So this is going to be motorcycle. Okay. Then we get a big one, bus, 135. So again, we line that up. Okay, put the center, the crosshairs at the center. Whoops. I want to line that up with the line that I just drew. And then we're going to count out 10, 20, 30, all the way out up to 135. Okay, that was a big chunk, just like the car. So here we go. This is the bus. Bicycle is 18 degrees. And again, that's kind of small, so I line that center up, run it along the side, the radius here, then, what was it, 18? 18 degrees. So, I mean, here's 20, so 18 is going to be just a couple degrees shy of that. There's my center. Draw that out. That was bicycle. Okay, now I know that was kind of long and slow there. I have got one section left. It should be 27 degrees. I'm going to extend my initial radius here so that I can measure this, and I'm hoping that I get relatively close to 27 degrees there. That'll kind of confirm for me that I did it correctly. And oh, look at that. 10, 20, 25. I'm closer to 26 degrees, but yeah, I feel really good about that. And this is the group of people that walk. And so now we've got a really nice visual about proportionally how many people travel to school in these different ways.